Okay, review for the finals assessment, polynomial equations and functions. Anytime I got higher than a 2, the graph just goes all over the place. No rhyme or reason. You got to pick 3 through -3. You punch these into your calculator, and here's what you get. 8, 8, -2, -10, -4, 28, 98. I don't really care to graph that one, so I will count by 5s, so 3, 8. So 1, 2, 3, 5. Here's 8. 2, 8. Going to be just basically right across from it. Again, there's no rhyme or reason here. 1, -2. At least that you're going to be real interested. 0, -10. -1, -4. -2, 28, 5, 10, 15, 20, 25, 28. Okay, so now let's talk about how the end behaviors look. That is a negative, so this arrow needs to curve down. My highest power is odd, so if it's odd, the arrow's got to do the opposite. So since that's going down, that's going to go up. Now another thing, you notice how we cross the x-axis here, here, and here, 3 places. That's why when I solve these, I'm always looking for 3 answers for x. Okay, cross. Okay, simplifying exponential functions. Okay, I don't see any adding and subtracting, so I just simplify the factors. 7 times y. 2 times 2 is 4. 3 times 2 is 6. There are no negatives. I need to find what 7 to the 4th is. It's going to be 2,401 times y to the 6th. Okay, done there. Base is 16 times a times b. I've got 18 on bottom. Okay, so 16 and 18 are both to the first power. Now, a, I've got a -3 and a -5. Okay, that a is in the numerator. The other a is in the denominator, so we need to put a minus sign. But if I'm minusing a negative, I end up adding. That equals 2. So a is to the +2 power. And then b, I've got 4 and 7. It's an easy one. Okay, the first b is in the numerator, the other b is in the denominator, so I minus, and that's -3. Okay, so that b, everything else stays in the same place, but the b's got to move into the denominator so that it becomes positive. Okay, so it's going to be 16 over 18, and then a to the second and b to the third. Now, these two coefficients are on opposite sides. Now, if they would be on the same side, I would multiply them, but when they're on the opposite side, we need to reduce them by common factors. So I can divide them by 2, that's 8, and that's 9. Okay, next one. Again, no adding and subtracting. 6 and 2 are your bases numerically. The variables, we got x and y. 6, 1 times 2 is 2. 1 times 3 is 3. For x's, I've got 3 times 2 is 6, and then another 6, because 2 times 3. Okay, it looks to me like those are both in the numerator, so we add, and that gives me +12. So x is to the power of +12. Now the y, we have -4 times 2 is -8. Okay, so we got to take that and move it. 6 to the second's good where it's at. 2 to the third's good where it's at. X to the 12th's good, but y to the 8th's down there. Okay, 6 to the second's 36. 2 to the third's 8. And then I've got x to the 12th, y to the 8th. Now, you do not add the two coefficient numbers. The adding is for exponents. The big coefficient numbers, I do what it says, 36 times 8, and that's 288. So that needs to be a product of 288. Okay, whatever's there, I don't care what it was. I'm not going to worry about that. I'm just going to use 3a and b for the bases. Okay, so 3 times a times b. So 3 is to the first. Now for a, I've got 3, 2, and 2. Numerator to numerator, and then that's on bottom, so that's denominator. So we plus and minus. Pretty simple, it's 3. So the a is to the third power, positive. B, I have negative 2, 3, and 2. So negative 2, 3, and 2. Okay, the first b is on the numerator, but then I move into the denominator. So I minus, and then I don't stop. I keep minusing. Negative 2 minus 3, it's going to give you negative 5. Minus 2 is negative 7. So b is to the negative 7. Okay, so I need to keep the 3 to the first and the a to the third where they belong. B to the seventh's on bottom. And then 3 to the first is just 3 times a3, b7. Okay, my next problem. This time we have adding and subtracting going on with the exponents, so we need to use a different technique, and that's to duplicate and use the FOIL method. So 4x times 4x. 4x multiplied by negative 2. Negative 2 times 4x. Negative 2 times negative 2. So 16x squared, negative 8x, negative 8x, and 4. So that ends up being negative 16x plus 4. Okay, now we're solving some equations by factoring. I have x to the fifth, so there needs to be 5 of these. I think I have those for you on the actual test, but there's 5 answers. At least I think there are. So 3 terms, so I will be looking for my GCF, and then I will be using my T-chart. GCF, we don't have a negative, we have x on everything, with x being the smallest, and then we can divide all these by 2. So 2x is GCF. You need to circle that because that is used to get one of the answers. Okay, so then I get 1x to the fourth minus 28x to the second plus 75. 1 times 75 is positive 75, so you're looking for a sum of 28, and you get that with 3 and 25. Okay, so now what does A equal? A equals 1. That's good, but what's not good is the fact that it's x to the fourth. So you need to put it as x second, and then 3 and 25. So minus 28, that means you got minus 25, and it's a sum, so it's minus 3. Okay, this is not, 3 is not a perfect square, that's prime, circle it. That is a difference of perfect squares, so you need to break it down. Plus minus xx, 5, 5. That's prime, and that's prime. So what did I have? I had 2x times x to the second minus 3 times x plus 5 times x minus 5. Now solve them. 2x equals 0. 0 is answer number 1. X to the second power minus 3 equals 0. Okay, you need to do the square root. Now that could be a positive, negative. You don't do the I, it's not negative, and 3 is not really divisible by anything, so I just leave it as the square root of 3. And those are 2 answers, positive and negative. X plus 5 equals 0. I get negative 5. X minus 5 equals 0. I get 5. Okay. All right, next one. X to the third, 3 answers. This time there's only two terms, so GCF, and then I see if we have a difference of perfect squares. Okay, GCF, you got 2x. Circle that because we use that later on. And now I'm at 1x to the second minus 36. Is that a difference of perfect squares? Sure it is. 6 times 6, and this would be x times x, or 1x times 1x, if you prefer that. Okay, well that's obviously prime, and that's minus, but it's still prime. So I've got 2x times x plus 6 times x minus 6. Okay, so 2x equals 0, x plus 6 equals 0, x minus 6 equals 0. So 0 is our first answer. Negative 6 is the second. Positive 6 is the third. Okay, 3 answers to this. We got 4 terms though, so we got to set up the grouping. Grouping, parentheses plus parentheses, space parentheses plus space parentheses, space parentheses. So we've got 1x cubed plus 5x squared and negative 9x minus 45. Okay, we'll be dividing these both by x squared. Can't really do much with 1 and 5. And these by negative 9, you're not going to be dividing by x here. So x squared gets yanked out, negative 9 gets yanked out. So it's going to be 1x plus 5 and 1x plus 5. So since we got 1x plus 5 inside both, then we have x second minus 9. Okay, this bad boy's prime, so we'll circle him, but that breaks down because you got x times x and 3 times 3. Okay, now that's prime and that's prime. So everything's prime, so I've got 1x plus 5 times x plus 3 times x minus 3. Okay, so 1x plus 5 equals 0, x plus 3 equals 0, x minus 3 equals 0. So I'm minus 5, I get negative 5. And then you're going to get negative 3 and positive 3. Okay, well, next one. Solve the equation. There's 3 answers, but it says here it's not going to factor. So with 4 terms that won't factor, you need to be ready to use your synthetic division L. Okay, so I will be first testing in 1 to the third minus 4. You just trial and error, basically, hoping you can get something quickly. Oh, I did. 1 worked. Okay. So I will be synthetically dividing by 1. So my coefficients are 1, negative 4, negative 15, and 18. So 1 times 1 is 1. And we add, it's negative 3. Times 1 is negative 3. Okay, so now what did that accomplish? It took the 1 and made it x third. Now it's 1x squared minus 3x minus 18 equals 0. Now I'm going to use a GCF, which I don't think I have one, and then my t-chart. So negative 18, difference of 3, that's going to be 3 and 6. A equals 1, so it's just XX, 3, 6. And I have minus 6 and difference be plus 3. So the x plus 3 could equal 0, or x minus 6 could equal 0. So I get negative 3 and positive 6, man. Okay, now for some story problems. From 1998 to 2005, the sales of sporting goods can be modeled by the equation you get a big crazy equation, S equals 0.007 t to the third plus 0.1 t squared plus 1.4 t plus 70. T is a year since 1998, and S is the sales in billions. Calculate the sales in 2005. Really a pretty easy problem. S is the sales, and that's in billions. Bill. And then T is years, but it's years since 1998. Okay, so what I'm asking to do at the end, calculate the sales in 2005. So I take 2005. Now, obviously, that's a year, so it has to do with T, but we need to minus 1998, and that's 7. So I'll be putting 7 in for all these T's, and then I can find what S would equal the sales. So 0.007 times 7 to the power of 3. Plus 0.1 times 7 to the power of 2, plus 1.4 times 7, plus 70. I got 87 approximately, so S is 87 billion. Really pretty easy problem there, but the last one's a lot harder. One of the costs to print a novel can be modeled by the equation C equals x cubed minus 10x squared plus 28x. X represents a number of novels in thousands. C represents the cost in thousands. Company is now printing 5,000 novels at a cost of $15,000. What other numbers of novels would cost the same amount? C and X are the variables. C is the money, and that's in thousands. We'll just put K. Then X is the novels. That's in thousands, and we'll put K. Okay, so what numbers they gave me? Well, they told me that 5,000 novels equals $15,000. Okay, so what I need to do is insert these each into the equation. So it's 5 is the X, okay? And the 15 is cost, so that goes in for C. So 15, and then we're going to put 5s in for all the X's. And the point of that is just me just verifying that, yeah, putting 5 in actually does give me 15. Okay, like a boss, it does, okay? So we want to keep the cost at 15. But we need to switch these back to X's. Because I want to find out different X's that can be a cost of 15. So there's 3 answers. And what's even better is that I know that one of them is already 5. So if I already know one of them, we're using the synthetic division by 5. So I need to minus 15, get him where he belongs. So I have 1, negative 10, 28, and negative 15. 5, it's negative 5, negative 25. Remember, I'm multiplying and then adding. Okay, so now what that does to the 1 is it takes it to 1x squared minus 5x plus 3 equals 0. GCF I don't think works. I know it doesn't. 1 times 3 is positive 3, sum of 5. That's impossible, so we got to use our quadratic formula. Opposite of b is 5 plus or minus c square root b squared minus 3 in a row. Okay, so negative 5, 4, a is 1, c is 3, then 2 times 1 is 2. 5 plus or minus, and then 2 on bottom. Okay, now I'm going to plug that into my calculator. It's not going to be a domain error, so you might as well just forget that. Okay, so I got 3.6. Okay, so 5 plus 3.6 divided by 2 is 4.3. 5 minus 3.6 is 1.4 divided by 2 is 0.7. Okay, all those are legit answers. Okay, you can do 5,000 novels, 4,300 novels, or 700 novels is what that means.